Hello students, good morning. Welcome to today's session. So today's session will discuss about the textbook problems which are based on mirror formula and magnification. So once again we'll recall what is the magnification formula and what is a mirror formula. What is mirror formula? 1 by f is equals to 1 by v plus 1 by u, and the magnification m is equals to height of the image by height of the object is equals to minus v by u. So based on these two formulas we have to solve the problems which are given in our textbook bag, and one problem is given as an example sum. So all the problems in today's class I will explain in this video. Okay, let us start with the example sum. Here I wrote that example sum on the board. An object 4 cm in size is placed at 25 cm in front of a concave mirror of focal length 15 cm. At what distance from the mirror would a screen be placed in order to obtain a sharp image? Find the nature and size of the image. Just first you read the problem one time, or if you are not understanding, then again you start reading the problem. After reading, first you find out what type of mirror is given in the problem. So here what type of mirror is given? Concave mirror. What is given? Concave mirror. So first you have to take a concave mirror. Okay. Now just try to draw the ray diagram of this concave mirror. Means pole, it has a focus and it has a center. Now again start reading the problem. An object 4 cm in size means height of the object is given as 4 cm. Height of the object is given as 4 cm. Now slowly start reading, and what are the values are given, then start writing. Is placed at 25 cm in front of a concave mirror. An object is placed from the mirror at a distance of 25 centimeters. Means object distance is given as 25 centimeters. Next, a focal length 15 centimeters. So that focal length of that mirror is how much? 15 centimeters. At what distance from the mirror would a screen be placed in order to obtain a sharp image? So, an object is placed in front of a concave mirror, and object distance is given, focal length is given. They are asking to find out where you have to place a screen to catch that image. So, you have to find out the image distance. What is the image distance? So to find out these values, we have to go for the sign conventions, whether these values are positive or negative. Object distance is 25 and focal length is how much it is given? 15. Focal length means from the pole to the F. So pole to the F, P to F is given as 15 centimeters. All the distances we should start measuring from the pole to, we should start from the starting point is pole. So this is 15 centimeters. Okay. And if P to F is 15 and then P to C. P to C is double. There is a relation between radius of curvature and focal length. What is that? Radius of curvature is equals to 2F. So R is equals to 2 into this 15, then it becomes 30. From P to C is 30 centimeters. This is 15 and this is 30. Now coming to the object distance, where they placed an object at a distance of 25 centimeters from F P to F is 15 and P to C is 30. So in between 15 to 30, they placed an object. At what distance? At a distance of 25 centimeters. At a distance of 25 centimeters. So in between F and C, they placed this object. Now try to draw a ray diagram. So from this object, the light rays enter on this concave mirror. This is the incident ray. Then reflected ray passes through the focus. Reflected ray passes through the focus. And we will take one more ray, a ray which is passing through the focus, and the reflected ray is passing through the which is parallel to the principal axis. So here you will get the image. Here you will get the image. So just ray diagrams, no need to draw, but to understand clearly about this problem, you just try to draw. Now this is the ray diagram. Now we have to find out the sign conventions. This is the incident ray. This is the incident ray direction, but focal length is towards this direction. So both are in the opposite direction. So both are opposite means you have to take it as negative sign. Focal length you must take it as negative. And object distance. Object distance is placed from P to somewhere here 25. Object means A will take it as 25. So P to F is like this. Incident ray towards like this, and object distance we are measuring towards this. So this also both are opposite direction. We must take it as negative. Both are same direction means we must take it as positive. And the distance which is opposite to the incident ray, that we must take it as negative. So both are opposite, I took as negative. And here object distance means we must take it as negative. Now from the mirror formula, so how you will find out V value? From the mirror formula. From the mirror formula, what is that? 1 by F is equals to 1 by V plus 1 by U. Now you want value of V. So just you take it 1 by V this side and bring this U this side. Then becomes 1 by V minus 1 by U. Substitute the values. 1 by F means minus. So I will write it as minus 1 by 15 minus 1 by U means how much? Minus 25. Minus 25. So 1 by 15 minus it becomes a 15. 1 by 25. Then take LCM of 15 and 25. So 15 comma 25 LCM. 5 3s are 15, 5 5s are 15. You have to take the LCM till you get the prime numbers. So these two are prime, so no need to take like this 3, 5 and so on. Okay, next. 5 3s are 15, 15 5s are 75. Okay, now minus 1 by 15 into this 15 in 75, how many times going? 5 times. So write it to 5 plus 1 by 25 into 25 3 times. It goes 3 times. Then minus 5 by 75 plus 3 by 75. So when denominators are same, then easily you can simplify the numerators. Minus 5 plus 3. Then you will get minus 2 by 75. Minus 2 by 75. Actually, we want V value. Here we are finding 1 by V. So 1 by V we got it as minus 2 by 75. Then either you do cross multiplication or reverse the values. If you reverse V by 1 you will get V by 1 means V only. and here you will get 75 by 2, minus 75 by 2. So minus 75 by 2 means how many times it is going? 3 times, and 7 times 14, and 5 times 10, 0. So V you are getting as minus 37.5 centimeter. Here V means the image is formed at a distance of 37.5. Means from the pole, if you place a screen at a distance of 37.5, then you will catch the image on the screen. Here the negative symbol represents what? Here the negative symbol represents what? Means this negative symbol represents for the concave mirror is the image is a real image and it is opposite to the incident ray. I mean the image is formed opposite to the incident ray. See here, image is formed here and the incident ray is here. Means the distance when you are measuring. Now, okay. So we got it. At what distance from the mirror would a screen be placed? Means you have to find out V is equals to what? Next, find the nature and the size of the image. Nature of the image means that it is real image or virtual image, that you have to find out. Here we got it as it is a real image because actual intersection of the light rays, they are converging here through the ray diagram, and from the value of V also we got the same value, negative symbol. So negative symbol indicates here it is a real image, and here the size, actually size we have to find out. So to find out that, we have to follow the magnification. So magnification is equals to height of the image by height of the object is equals to minus V by U. Just nature means you can find out whether it is real or virtual. So it is a real image. Then find the size of the image. So what is the size? We don't know. What is the height of this? So that to find out, we have to follow the magnification. In that magnification, you have the formula, height of the image by height of the object is equals to minus V by U. So now substitute the values. Height of the object is given. Is given a no. Sorry, is given. Height of the image, that we must find out. So you have to write it as height of the image, and the height of the object is given as 4 centimeters. And for this also we must take the sign conventions. When an object is above the principal axis, we must take it as positive. So it is above the principal axis, so it is positive. So here you directly take it as 4 centimeters. Next, minus image. How much we got it as the image? Minus V value, again we got it one more minus. So that is minus 37.5 by U. U is minus 25. Don't confuse that. So these negative symbols and the positive symbols. So negative symbol, negative will both get cancelled. Then height of the image is equals to 4 minus 37.5 by 25. Now do cross multiplication and find out the value. H of the height of the image is equals to, do like this. Whatever you want to find out, that you must write it in the denominator. Minus 37.5 into 4 by 25. So if you here decimal to do cancellation, simplification, if it is hard means just you multiply to remove this decimal with the 10 by 10 on both the sides, like numerator and denominator. Then you will get 375 into 4 by 25. Sorry, 250, because here one more is there. Now we'll start with the cancellation. So 25 in 10 times it goes, and here 25 one time. 375, how many times going? 25, 125, and 2, 125, means 5 times. So 15 times. 15 times. 15, 6, 4 are 60. 60 by 10. Then you are getting as 6 centimeters. Height of the image you are getting as 6 centimeters. Height of the image is equals to 6 centimeters. And is there any negative symbol? Yes. We have to take that symbol also. Is negative. So when you will get the height of the image negative symbol, if that image is formed below the principal axis, if the image is formed below the principal axis, that will consider as negative. So here negative means the image is formed below the principal axis. And here the size, what is the size of that image? That is 6 centimeters. Object size is 4 centimeters and the image size is 6 centimeters. So then the object size, image size is more. Due to that, we got it as a real, inverted and enlarged image. So we got an image, real, inverted and enlarged image. So this is about this example sum. It is given in the textbook. Is it clear, students? See, note on this. I will send the notes. Okay, just follow the steps. Okay, now I'll explain the one more textbook problem which is given in the application of concepts. Which is given in the application of concepts. Here, find the distance of the image when an object is placed on the principal axis at a distance of 10 centimeters in front of a concave mirror whose radius of curvature is 8 centimeters. So, read the problem first and immediately you find out what type of mirror is given in the problem. So, here what type of mirror is given? Concave mirror. When the mirror is given, just to understand, to get the values clearly, the sign conventions, better to draw the ray diagram. This is concave mirror and this is pole, this is focus and this is the center of curvature. Okay, now find the distance of the image. So you must find out V is equals to how much from the problem. When an object is placed on the principal axis at a distance of 10 centimeters from the pole on the principal axis, an object is placed. It means object means U is placed at a distance of 10 centimeters. Concave mirror whose radius of curvature is 8 centimeters. So radius of curvature is given as 8 centimeters. So what are the values are given? Just you write them. Again, these values we will find out through the ray diagram. See, first we have to find out whether the radius of curvature or the focal length. Then only we will find out where the object is located on the principal axis. Here R is given. R is how much? 8 centimeters. So R means from the pole to the center. From the pole to the center. So you have to measure from pole to center. This is how much? 8 centimeters. If there is a relation between radius and focal length. So radius from this, okay. Radius is equals to 2f. So f is equals to r by 2. So you will get r is equals to F is equals to R by 2 means 8 by 2. Then F you will get it as 4 centimeters. Okay. So from P to F, you are getting as 4 centimeters. Without calculation also you can write it, because always it is half from the radius of curvature focal length. Next, object is placed at a 10 centimeter from the pole. So this is 4 and this is 8. 10 means beyond, see somewhere here they placed an object. So from P to this object, I'll take it as A. This is 10 centimeters. Each line I'm drawing the direction, because this direction indicates we are measuring the distances from the pole. Is it clear? Now try to draw the ray diagram. So from the object, the light rays from this object, the light ray travels and falls on this concave mirror in this direction. When it falls, when a ray is parallel, then the reflected ray passes through the focus. And next, when a ray is passing through the focus and the reflected ray is, 1 minute. The reflected ray you will get, these reflected rays will converge at this point. Okay, this already I explained in the previous videos. Okay, now this is about radius and this is the focal length and this is about the object distances. Now, to find the value of V, we must take the sign conventions. So, incident ray is towards this direction. Incident ray for U. Where is this U? Incident distance you are measuring like this, but the incident ray is towards like this direction. So then object, it becomes negative. Both are in the opposite direction. Next, focal length. Focal length also same. The incident ray is towards this direction. Both are in the opposite direction. So we must take it as F is also negative. Simple. Then R is not required. So U and F we got it, and we'll substitute in the mirror formula. So from mirror formula, one by F is equals to 1 by V plus 1 by U. Again you have to find out what is V. So from the equation, 1 by V is equals to 1 by F minus 1 by U. And 1 by F means how much here? We got it minus 4. So substitute minus 4 minus U means how much? Minus 10. Simplify these values. Here 1 by minus 1 by 4, minus minus it becomes plus, minus into minus plus, 1 by 10. What is the LCM of 4 comma 10? 4 comma 10, 2 2s are 5. 2 2s are 4, 4 5s are 20. Then write it minus 1 by 4 into this. 4 in 20, how many times going? 5 times. So must write, you multiply, or you can do in your own way. Simplification. And this 10 into 2 times it goes. So minus 5 by 20. So just multiply numerators and denominators 2 by 20. When denominators are same, just simplify the numerators. Minus 5 plus 2, then it becomes minus 3 by 20. Minus 3 by 20. Here I will do the remaining problem. So we got it as 1 by V is equals to how much? Minus 3 by 20. So from this you find out V value. Reverse it. V by 1, 20 by 3. So you will get minus 20 by 3. So 20 by 3 means you will get so repeating this one, sorry. So this is repeating, endless. Then V value will get it as minus 6.66 and so on. So that we will write it as minus 6.67. You can write or leave it like that. Nothing will happen. Then the units are centimeters. Centimeters or meters? Once let me check. Centimeters only. Here I took as centimeters in front of a concave mirror. Yes, centimeters. V you got it as negative. If V value is negative, then it is a real image. Then it is a real image for a concave mirror. For a concave mirror. It is a real image and it is just they asked about the find the distance of the image. Just they asked about what is the V value. They did not ask about magnification and nature, size like that. So this is enough. This image is negative means it is a real inverted image and from the pole at a distance of 6.67 centimeters. This is the application of concept first problem, and one more problem is given in the higher order thinking questions. Okay, that also I will explain now. See students, in the higher order thinking questions, first question is the same problem is given. So what is that? Higher order thinking questions. In that first one, a convex mirror with a radius of curvature with a radius of curvature of 3 meters is used as rear view mirror for a vehicle full stop. If a bus is located at 5 meters from this mirror, find the position, nature and size of the image. This is the problem given. So for this we have to find out the solution. So once again I will read, then after I will explain. A convex mirror. Here what type of mirror is given? A convex mirror with a radius of curvature 3 meters is used as a rear view mirror for a vehicle. Some vehicle is there, bus or something. Your side view mirrors are taken as a convex mirror. If a bus is located at 5 meters from this mirror, find the position and nature and the size of the mirror. So when a vehicle is going behind this mirror, a bus is there. So that bus, it is located at a distance of 5 meters. Then for this on this mirror, what type of image of the bus we get, what type of image and nature of the image, that all we must find out. So I said, when a problem is given, first you have to find out what type of mirror is given. Here a convex mirror is given. So first you draw the convex mirror. Convex mirror means it is bulged outwards, and this is the pole, and this is the focus, and this is the center of curvature. Actually, in the ray diagram we have discussed about the convex mirrors. Wherever you place an object in front of a convex mirror, always we get image in between focal length and pole, and that is diminished image and virtual image. That is virtual, erect and diminished image. So now they are asking about the position. So image, nature, size also they ask, nature also they ask. So once we'll find out. A concave mirror with the radius of curvature 3 meters. Radius of curvature means from P to, here I will draw, from P to C. This is P to C is known as radius. So P to C means arrow is like this direction. This is how much? 3 meters. Next, as a rear view mirror for a vehicle. If a bus is located at 5 meters, bus is located from the mirror at a distance of somewhere 5 meters. Here, this is an object. This bus is located an object, that we will take it as AB. So here object is placed in front of a convex mirror. So P to C is known as radius. If radius is given 3 meters, then you can easily find out the focus. Focus is always half of the radius, because there is a relation between radius and the focal length. R is equals to 2F. F is equals to R by 2. Then R is how much? 3. 3 by 2. Then you will get 1.5 meters. So from P to C, sorry, P to F, this it becomes 1.5 meters. Then I will write here values. F is equals to minus, sorry, no, don't take values, just write don't take signs. 1.5 meters. And object distance is you have to measure from pole to object. So object, here I will draw object distance is from pole to A. This is how much? 5 meters. So U is, you have to take it as 5 meters. Now from this bus, if a ray is falls on a mirror, convex mirror, the reflected ray diverges, and this diverging ray coming from the focus, and if a ray is passing through the center of curvature, then the reflected ray is also passing through the center of curvature, and these two diverge rays are converging in between F and pole. Focus and pole, that already we discussed. Okay. Now we have to take the sign conventions. Incident ray is towards this direction, and distance U is towards this. So you must take U is equals to minus 5 meters. Both are in the opposite. Next, F value also. F, P to F. Where is this F? P to F, and incident ray also towards this direction only. So both are in the same direction means you must take it as positive. So positive means no need to write plus. Next, so to derive the formula from the mirror formula, 1 by F is equals to 1 by V plus 1 by U. So you got it U and you got it F. Then find V. So V means 1 by V is equals to 1 by F minus 1 by U. Substitute the values. 1 by, so I can't write from that side. F here we got it as plus, here meters. So 1.5 minus 1 by U is how much? U is minus 5 meters. So write it as minus 5. So your decimal is there means to remove this decimal here I will multiply 10 by 10. Then it becomes 10 by 15. Minus minus will cancel. We'll get it as plus. So what is the LCM of 15 and 5? 15 only. Then 10 by 15 plus 1 by 5 into 3 by 3. This is 5 and 15 LCM. So this is 15 in this one. So no need to write 1 by 1. This is 5 in LCM 3 times. 3 by 3 you must write it. So when you multiply numerators and the denominators, you will get like this. Denominators are same. When the denominators same, just simplify the numerators. 10 plus 3, both are positive. You are getting as 1 by V is equals to 13 by 15. 13 by 15. Then reverse it, you will get V is equals to 15 by 13 meters. And simplify 15 by 13. 15 by 13 one time. Then 2, 0. Again one time. 7. So 0, 6 times 6, 13s are 13 only, na? 5 times. It goes 5 times 65. So like that you will get just decimal after 2 digits. Just you take it and you stop the division. Then here V you will get it as 1.15 meters. Here V is a positive. If V is positive, then it is towards the incident ray. That image is formed towards the incident ray. So V is positive means the image is formed towards the incident ray. Next, position, nature and the size of the image. The size also they asked. So to find out the size, we got it only the V value. We got it only the V value. And when you compare this U and V, U is 5 meters, V is 1.15. So V is a diminished image. V is a diminished image. And what is the size of the diminished image? That we must find out. To find out, we have to use the magnification formula. Because here they asked about the size. To find out the size, you have to use magnification formula, that is. So magnification formula, M is equals to minus V by U. If the height of the object is given, then you must use H of I by H of O. But now no need. The height of the object is not given. So no need to write that one. Just you take it minus V by U. Then minus of V means 1.15 by U is how much? Minus 5 meters. Minus 5 meters. So minus minus will get cancelled. 1.15 by 5. Then just simply 115 by 5 you do. 2 5s are 10, 1, 5, 3, 23. You are getting as 23. Your decimal is there, or if you are confusing to cancel and to simplify like this, just you multiply 100 by 100. Then you will get 115 by 500. Then you can write it as 115 by 5 into 100. Then how much you will get? 115 by 5 into 100. 5 in this, 2 5s are 10. 3 5s are 23. So you are getting as 23 by 100. Then you will get point. When you are dividing with the zeros, the decimal moves towards the left side. So you are getting the magnification value is 0.23 meters. Means the size of that image is there is no symbol, 0.23 meters. This is about the problem. Position, where you are getting that position of that image in between F and focus and pole, and behind the mirror. I forgot to explain that. The image is formed behind the mirror, and nature is virtual image and erect image, and the size is small, diminished image. This is about a higher order thinking question. And one more problem is given. If the magnification value is +1, what does it mean? Means when you will get the magnification value is +1, when you will get when object image distance and the object distance, if both are same, then you will get the magnification value is 1. So where you will get that value? When you place an object at C on the principal axis, you will get the image at the same below the center. What is that? You will get an inverted image and below the principal axis. So plus means +1 means you will get M is equals to minus V by U. Minus V by U means 5 by 5 object, then both will get cancelled, you will get a +1 only. So like this some examples are there. So when you place an object in at center on the principal axis, or you will get the image at the same center of the curvature. And one more is, if V and U are, we will get the magnification value is 1. So this is about the textbook problems which are given in 10th class Telangana State Board. I hope all you understood all these problems. Okay students, thank you. Have a nice day.